Section 1.5, Determining Limits Using Algebraic Properties of Limits. So we're going to talk about the properties of limits. To start with, we're going to talk about this one right here. The limit as x approaches a constant of a different constant equals that number right there. Let me describe why. Let me show you an example and describe why. So you have the limit as, say, x approaches 8 of, say, 5. Well, the answer to that would be 5. The reason? Well, 5. If 5 is a function, there's no x on it. So if you try to put 8 into 5, the answer is 5. No matter what you put into 5, it's 5. And 5 is a constant. It's a continuous function, so there's not going to be any errors to it. So basically, 5 is 5, no matter what you try to plug in or find the limit at. So constant is the answer, is the constant. Next one, right here. The limit as x approaches c of x is the c you plug in. The reason for that is x is just a function. It's a line. All right? And when you plug in c to that line, you get c. Here's an example of what it would look like. You have the limit as x approaches 7 of, say, of x. That would just be 7, because you're simply plugging 7 into that. Next, let's talk about this right here. The limit as x approaches c of a function plus or minus another function. That would be equal to each limit plus or minus the other limit individually. This is two separate limits. So if it was f plus g, it would be f plus g. If it was f minus g, it'd be f minus g. So when you take the limit of two things inside, you're basically taking the limit of each one individually. And here's kind of what that would look like. The limit as x approaches 5 of f of x, say minus g of x. All right, let's say I have that. That would be the limit as x approaches 5 of f of x minus the limit as x approaches 5 of g of x. You would do each one individually. Next, this one is very similar to this one. Instead of a plus or minus, it is a multiply. And if you look carefully, you do this one, you just end up making each function individually and multiply each one individually just the same as this. So I'm not going to write the whole thing over again. It would just be the whole thing, but where there's a minus, I'd have a multiply. And then this one is very much the same as these two, because if you divide, you just simply take the limit of each and divide each, provided that the denominator cannot equal 0. That's the key. You can't have that equal 0. That's one issue with fractions. You can have errors and stuff. So you have to watch out for that one. But basically, this, again, is the same as both of these, so we don't need to write an example. Alrighty, so let's now talk about this one. This one is very similar to this one. Let me show you an example of it. If I take the limit as x approaches 3 of, say, 8 x, not 8x, but 8 f of x. Okay? So let's say that's what we're taking the limit of. The answer, according to the rule, is going to be 8 out front times the limit as x approaches 3 of f of x. That's the rule. Now, why is that the case? Why is that the case? Well, this is really the same as this. Do you see I have two separate things? Do you see I separated them? So we separated them. Now, you might not see exactly why I'm saying that, but really this is saying the limit as x approaches 3 of 8 times the limit as x approaches 3 of f of x. And you might go, okay, what's this equal to? Well, this goes back to this one. Do you see that? So the answer to this one is 5. So if the answer to this one is simply, this right here is going to be 8. So now you have 8 times this, which is the answer. So you could do this whole work to every time, but or you could see the shortcut, that when you have a constant times a function, you can simply put the constant out front. It's kind of a nice little shortcut. Lastly, this one is exactly like this one again. So if you see a function squared or a function to the third power, you could think of taking the whole thing and take it to that power. So the example, what that looks like is the limit as x approaches 8 of, say, f of x to the third would be the limit as x approaches 8 of f of x all to the third. So that's what it's saying. But why is that the way it is? Well, the limit as x approaches 8 of f of x to the third means f of x times, let's see this, times f of x times f of x. Isn't that what the third, this right here means the third means? And if you think of all three of these, isn't that really just saying this property? And if you have three of them, well, isn't cube just means anything times itself 3 times. So you can basically, when you see a third, see 3 of these, which means you have 3 of these, which means you cube it. It's just a really quick shortcut. So if you see, again, a power out here, you can take the whole thing to a power, because really you have to remember that powering is quick multiplication. So you're really going back to this property once again.